Hello everyone, in the last video we have implemented copy constructor in the account holder class. So declaration of copy constructor is like this and definition of copy constructor is written here. So we have seen how dangling pointer happens and why user needs to write its own copy constructor. Now let's discuss one more thing, which is why the argument to the copy constructor must be passed by reference. Now what is that thing? So let's discuss. So here if you see the declaration or definition of the copy constructor, argument to that copy constructor is by reference. Here ampersand is there. Now let me pass it by value. Suppose I remove the ampersand sign from the declaration as well as from the definition. So let me do that thing, and now let's compile. Account holder .cpp is the file. So it is not getting compiled. That means when I remove the ampersand sign, it is not getting compiled. Previously it was compiled. So if I undo the changes, so ampersand here and ampersand here, then it is getting compiled. But when I remove the ampersand, it is not getting compiled. So that means compiler is not allowing the argument to the copy constructor by value. It is mandatory to pass the argument to copy constructor by reference. So now let's discuss the reason behind that. So let me create one new file. So I will write one new class which is say test class. So name of the file will be test.cpp. So what I do, I write some class here which is class test. So in this class I do not have any data member as such, but I write few functions, like I write default constructor, then I write parameterize constructor, then copy constructor I write. So copy constructor for test class will be class name is test and argument will be also test, and I have to pass it by reference. So this will become copy constructor for test class. Let me also write the destructor for test class. So destructor will be something like this. Now in the definitions of these functions like default constructor, parameterized constructor, copy constructor and destructor, I write single line statements which will display the messages. So let me include IOStream using namespace std here, and I will define the function. So default constructor test scope solution test. In the default constructor I simply print message cout default constructor. Then in the parameterized constructor, message is parameterized constructor. Then copy constructor, will have message copy constructor, and destructor will be there. So in the destructor, let me print destructor. Now I will write main function, and in main function I will write some piece of code, and you are supposed to predict the output of this code. So suppose main function is there. In the main function, initially I create one simple object of test class, say test t1. That's it, and I compile and run my program. So let's again go through the code. Test class is there which is not having any data member, and there are few functions: default constructor, parameterized constructor, copy constructor and destructor. In each function I have printed the appropriate message, and in the main function now I have created object of class test. So let's compile and run this program. So what will be the output in this case? Name of the file test.cpp. Line number 11, there is an error, semicolon missing. So now if I run, the output is default constructor and destructor. So that is correct, because whenever T1 object is created, default constructor is called, and when the return 0 has occurred, it will call the destructor for T1 object. Now instead of only T1, if I create 3 different objects, say T1, T2, T3, then what will be the output in this case? In this case, if I compile and run, the output is 3 times default constructor and then 3 times destructor. So that is okay, because the constructor is called for each of the object T1, T2, T3, and then destructor is also called for each of the object, and that is called in reverse way. That means first for T3, then for T2, then for T1. Now let me change the code slightly. Suppose T1 object is created, then I create T2 object. So when I create the T2 object, I pass some integer value, and now what will be the output? So let's compile it, run it. The output is first default constructor for T1, then parameterized constructor for T2. Now T2 is created using parameterized constructor, so that is okay. So default constructor for T1, parameterized constructor for T2, then destructor for T2, and then destructor for T1. So this is what is the output. So yes, it's okay. So let's go for the next one. Suppose I create, okay, suppose this line I put it in a block, and I create one more object here, T3. Now what will happen? Now let me compile it, run it. First default constructor, so default constructor is called for T1. Then parameterized constructor is called for T2. After that, now this T2 is local to this block. That means whenever the block is over, the scope of T2 is over. So it will call the destructor for T2. So here destructor is there before it calls the default constructor for T3 object. So after that, default constructor for T3 object is called, then destructor for T3 object is called, and then destructor for T1 object is called. So output is default constructor, parameterized constructor, destructor, default constructor, destructor, destructor. So this is also okay. I am convinced. So suppose now in this code I have some global function. Say there is some function void fun, which is a global function. It is not a member function of class, and in this function I simply print function fun. So here it is function fun, and in the main function I create one object T1. After that I call the function fun, and after that say T2 object is created, which is another object. Now what will be the output? So it will be something like this. First it will call the default constructor for T1, then function fun, then default constructor for T2, then destructor. So let me compile it, run it. Yes, default constructor, function fun, default constructor, then destructor twice. So fine, let's go for next one. Suppose now this function fun is taking one argument. So now suppose here I write test t. That means that function fun is taking some argument of type test. So when I call that function, I have to pass some test object. So here I have to either, or here I have to say T1. I have to pass the test class object when I call the function. Now what will be the output? So let me check. If I compile it, run it, what is the output? First default constructor, so that is for T1. I understand that default constructor is called for T1. After that, function fun. So I am expecting function fun. Here what it is showing? It is showing copy constructor. It is not showing function fun. Function fun is printed later, but before that copy constructor is called. So now this copy constructor, why this copy constructor is called in this case? Because in my code I did not call copy constructor explicitly anywhere. So T1 is created using default constructor, T2 is also created using default constructor. So there is no object which I have created using copy constructor. So it is something like this. I do not have any such statement, say test, then some object which is created from some already existing object. So I do not have any such statement. still it is calling the copy constructor here. So now why this copy constructor is called in this case? So this copy constructor is called because this function fun. Now how that function fun is called, using which method? So there are three different methods. We know that there is a call by value, there is a call by address, and there is a call by reference. So function fun is called using call by value method here, because this t1 is actual argument and this t is formal argument. Now we know that what happens in call by value. In call by value, actual arguments gets copied into the formal argument. So this t1 is getting copied into this t, and for that copy it is calling the copy constructor. So default constructor is called for t1 object. After that, this copy constructor is called to copy this t1, which is actual argument, into the formal argument t. Now if that argument would be of some primitive type or built-in type like integer, character, float, then there is no call to the copy constructor, because primitives are copied automatically. But when I am passing object of my class, then to whenever copy of that object happens, then it has to call the copy constructor. So to copy that t1 object into t object, it is calling the copy constructor. So this copy constructor call is there since it is a call by value method. After that, you can understand the output. Function fun is there, so it is printed after that. After function fun, the destructor will get called here, because the scope of this t object is limited to that function. So destructor call is there. So you can see after function fun, destructor is there. Then default constructor is called for t2 object, so that is fine. Then destructor for t2 object, and then destructor for t1 object. So output will be default constructor for t1, then copy constructor for this t, then function fun, then destructor for t, then default constructor for t2, and then destructor for t2, and then destructor for t1. So this is the, you can say, drawback of call by value. Now let me make one small change. Instead of this thing, instead of passing that test object using call by value, let me pass it by call by reference. Now how to do that? Here I have to write ampersand sign for call by reference, and that's it. There won't be any other change. So suppose I write ampersand sign there, and now let me compile and run it. So now I see that into the output there is no call to the copy constructor. So first default constructor is called. So that default constructor is called for t1 object, that is okay. Then directly function fun is called because this method of calling function is call by reference. So in call by reference, there is no copy which is happening. The t is reference to the t1. So there is no separate copy. Reference is alias. It is another name to the already existing variable. So there is no separate copy, and that's why the copy constructor is not called. So after default constructor, directly function fun is there. After that, default constructor is called for t2 object, then destructor for t2 object, and then destructor for t1 object. So this is the output. So this is the biggest advantage of references over value. So in reference, there won't be any call to the copy constructor. So this thing is true for returning also. That means here, suppose if my function is returning object of test type, say I return some object, say return t, then this is written by value. So if I compile my code and run my code, you will see that again there is a call to the copy constructor. So this is because I have used return by value. Instead of that, so that copy constructor is called to copy this t into the temporary object. So whenever we return some object by value, it is copied into the temporary object, and for that copy it is calling the copy constructor. So instead of return by value, if I write ampersand here, so this will become return by reference. So again in this case, now there is no call to the copy constructor. Default constructor, function fun, default constructor, destructor. So what we need to remember, that whenever we pass an argument to a function, or whenever we pass object to a function by value, or whenever function returns object by value, then there will be called the copy constructor. And if we do not want that call, if I want to avoid that copy constructor call, then I have to make use of references. So I will note that statement here. So it will be something like this: whenever an object is passed to a function by reference or returned from a function by, sorry, not reference, it is by value. So whenever object is passed to a function by value or returned from a function by value, then there will be a call to copy constructor. And to avoid this copy constructor call, use pass by reference. So instead of value, you have to pass the object by reference. So this is the important thing that you need to remember. Now this was something about pass by value and pass by reference, but our original discussion was regarding this ampersand sign. Now the original question was why the argument to the copy constructor is always by reference, why it is not allowing me to pass that argument by value. So now you will understand that. So suppose, so initially we have called function fun from main function. So suppose main is there, and from there I have called fun by passing some object t1, and say this is function fun which is taking object by value. So we have observed that during this function call there was a call to the copy constructor. So here intermediate call was there to the copy constructor. So here say I write copy constructor. Now we are calling the copy constructor itself from the main function. That means from main function, I am inside the main function, the test statement is like this: test t2 inside bracket t1. So this will call the copy constructor, and say this is how copy constructor is written: test inside bracket argument of same type, and suppose pass by value is there, so pass by value is allowed. So during this function call also, to copy the actual argument into formal argument t1, it will call the copy constructor. That means here also there will be a call to the copy constructor. So let me write copy constructor here. Now previously from main function I was calling fun function, so that is okay. Before function fun is called, copy constructor is called. Now from the main function I am calling copy constructor itself, and to call that copy constructor it is calling the same function which is copy constructor. That means to call the copy constructor it is nestedly calling copy constructor to copy actual argument into formal argument. So for this function call also, to call this copy constructor from main, it will again call the same copy constructor recursively to copy actual argument into formal argument. Again, to call this copy constructor from main, it will call the same function again to copy the actual argument into formal argument. That means it will keep on calling the copy constructor. So it will go inside the infinite recursion, or it will be stack overflow, and that's why the call by value is not allowed. If I write reference here, there won't be any call to the copy constructor, and infinite recursion is avoided. So if I remove the ampersand from the definition of the copy constructor, in declaration also, if I remove, then it is throwing error only, it is not allowing. So this is the reason. So I will note down this thing. So it is something like this: an argument to the copy constructor must be passed by reference to avoid infinite recursion, or you can say to avoid stack overflow. So if you like the video, please do like the video and subscribe to my channel. I will see you again in the next video.